Okay, so there's a quick video to help you out, Nick. This is I went to Desmos and graphed the equation that you wrote, which I think is the right equation for this problem. So good job on that. So this is what you would, and you don't have to use Desmos or whatever, but you could have just sketched it. But basically, I wanted to show you on the graph what you're coming up with. So when I solved the equation like you did, I ended up with negative 1.055, which, like you said, is not an interval. And you can see here that if I click on this, negative 1, what did I say? Negative 1.05. So that would be right here. You can see that it does hit 76 degrees right in there somewhere. I can't get small enough, but maybe I'll zoom in a little bit. Yeah, if I click right about there. See, there's negative 0.8. If I go up a little bit, there's negative 0.9. So that's, you can see it's right around there. So that's the answer you're getting. So if you look at the graph, then the problem is when it hit 76, it hit 76 a couple times. In fact, let's go in here and put y equals 76, and you can see. So you can see that there's the answer that your calculator is giving you. Here's another answer right here, and there's another answer right there, and there's another answer right there, and another one back there. So there's a whole bunch of them, as we knew, because we know the unit circle just repeats itself. But notice if you add 2 pi to this, that's going to take you all the way around to here, and you just skip the one you wanted. You see that? Or not 2 pi, if you add the full, you said you added the full period, right? If you add the period, you'd go clear over to here, and that's going to take you past. It's just skip this one. So what you have to do is figure out, how can I find that one? Well, there's a couple ways you can do it. You know that the distance from this maximum to there is going to be the same as the distance from this maximum to there, because of the symmetry of sine. Now, if we were to look at that on the unit circle, let's switch over here real quick. If you're looking at it on the unit circle, right, that negative answer you're getting is right here. And if you think about sine, the same answer is going to show up again, right, let's see, right there, right? And so this is the one we want. So notice if you go around to, if you add, for example, half a period to this, it'll take you over to that one, and you're not quite there. So basically what you've got to do, or the main thing you want to do is think about this distance right here is the same as that distance right there. So it looks like if we just go from half a period from the beginning and then add that value to it, you'll get to this this angle. Now I think it's easier to look at the graph itself, because again what you're going to look at here is, we got too many things in here, let's erase, let's get rid of that one, that one, that one. So this distance right here, from there to there, is the same as from here to there. So again, the symmetry thing is important. Now if we go back to the problem says, the average daily temperature first occurs at 12. So, so this is the average daily temperature here. So that's the average daily temperature. We know that little distance, if we erase all this stuff, that would be another way to look at it. This distance right here, from 0 or from negative 1.055 to the center is going to be the same as there should be a center right here, that distance, right? So let's put in y equals, what was the center, 73? Yep, 73. So you can see if we click on that one, so that's negative 1.055 away from the center. So that means this guy would be 1.055 away from the center. Okay, so that means so if we're looking at this graph thing, yeah, it's going down. So it goes down, back up. So we're talking about this guy right here. This distance is 1.055 from there. So if I go over here, and the place I'm looking for is right there, we also know that this distance is 1.055. Right? And we know that that spot has to be 6 because it's 1/4 of the period. Total period is 24, so this would be I'm sorry, that's not right. This is 2. That's a half of the period, right? So this would be 12. So it's 12 hours from there to there, another 12 hours to this other one over here, right? So we know that this is 12, so that means this one here would have to occur at 13.055. And again, we got that by adding the 1.055 to the 12. So if you go back to the unit circle here, right, notice that that's the same thing I talked about here. From here to here is 12 hours, because that's half a period. And this distance right here would have to be 1.055, because it's the same size as that one. Okay, hopefully that helps. I mean, there's a lot of different ways you can do it, but the key is knowing how far the answer that you got, how far away from it is from the middle or the top or the bottom, and then figuring out how close this is to the next middle or top or bottom. And again, having that sketch of the graph really helps to visualize, because you can see this is the answer that you got from solving it, and that's the answer that I want. Not that one, or there's another one back here. You know, there's a bunch of answers, but this is the one that was given to me. That's the one that I want. And then from that, you can calculate how to find it.